Okay, now this is really the crux of the thing. Trying to show if this set is linearly independent. We're trying to show this set is a basis for M22. It's linearly independent if and only if this matrix equation leads us to trivial solutions for C1 through C4, because this says a linear combination of the vectors in the set is equal to the zero vector. So that is the case. Well, we take this linear combination, I've abbreviated it here, say it's equal to the zero vector, and I should have an arrow over the zero vector. Okay? Well, if we expand all this and write it out, we get this matrix equation, which leads us to four simultaneous equations, which can be interpreted as this matrix equation, and that's the key thing we want to see. And this matrix equation gives you the trivial solution only for C1 through C4, if and only if this matrix is invertible. So if the matrix is invertible, it means we get only the trivial solution, meaning that the vectors are linearly independent. The vectors being these four matrices, because again, we're treating this M22 as a vector space. Okay, now the other condition is that for any matrix in M22, okay, for any 2 by 2 matrix, and I've got the subscripts wrong, but that doesn't really matter. You set this linear combination equal to the matrix A11, A12, A21, A22. You probably can't read that, but you know what I'm writing. This is just an arbitrary 2 by 2 matrix. And then this equation, if we write it out in this form, the only difference is going to be you're going to have A11, A12, A21, A22 instead of the zeros, meaning that you'll have the same matrix equation except you have the A11, A12, A21, A22 here. And then you try to solve for the C1 through C4. If the matrix is invertible, then you have a unique solution for C1 through C4. If the matrix isn't invertible, you don't. So that we conclude that you can get any vector in the space, meaning, of course, that the space is spanned by the set of vectors, if and only if again, the matrix is invertible. A solution implies the set spans, and this thing is wet, so it's not writing real well, but that happens if and only if the matrix is invertible. Okay, so in both cases, setting this equal to the zero vector or setting it equal to an arbitrary set of four numbers representing a matrix in M22, we have our result. And again, the test is the matrix invertible?